Good day everyone, and especially to our Professor Sir Nestor Musha Jr. Before we proceed on our topic today, I would like to introduce to you, I am Salas Rheaben and one of your reporter for today. And now, we will be discussing about the automotive wiring and wire repair. For our learning objectives, at the end of chapter 44, students will be able to first explain the definition of automotive wiring and wire repair. Second, discuss electrical terminals and connectors. Third, describe how fusible links and fuses protect circuits and wiring. And lastly, apply the steps for performing proper wire repairs to ensure safe and reliable connections. For the first one is, what is automotive wiring? Automotive wire is made up of plastic insulated copper strands. Copper is emphasized as a good, inexpensive, and flexible conductor of electricity, but solid copper wire breaks when repeatedly bent. Or ang automotive wiring o yung wiring ng sasakyan, ito yung tumutukoy sa mga system ng mga copper at connection na ginagamit sa mga sasakyan para maghatid ng kuryente and makasiguro ng tamang way ng operasyon ng iba't ibang electrical. Itong mga copper ay karaniwang gawa sa mga tanso na mahibla na may plastic na pambalot para mabigyan ng protection ang mga copper at maiwasan ang mga short circuit. Ang mga wiring harness naman ay mga nakaayos na group ng mga copper na nagsisigurado ng maayos at organisado yung pagdaloy ng kuryente sa buong sasakyan. For next is how fusible links and fuses protect circuits and wiring. Fusible links is a fuse that is made up of a short piece 6 to 9 inches long of regular copper strand wire, wrapped with a unique non-flammable insulation. The wire is generally 4 wire numbers smaller than the wire of the circuits it safeguards. For instance, a 12-gauge circuit is safeguarded by a 16-gauge fusible link. The thick special insulation on the wire can give it a bigger appearance than similar wires with the same gauge number. This image, ito yung mga fusible link na may special na uri ng fuse na matatagpuan malapit sa battery ng sasakyan at nakakabit siya sa junction block. May haba lamang yan na 6 to 9 na pulgada at yan yung nagsisilbing mag-release ng kuryente sa higit sa isang fuse mula sa bawat fusible link. Kung ang sobrang kuryente ay dumaan dahil sa short to ground o sira na bahagi, nangyayari ay matutunaw ang fusible link sa kalahati at ma-open yun para maiwasan yung pagkasunog. Ang ilang fusible link naman ay may mga label na nakapangalan na fusible link. Sa part nun kung saan siya nakakabit sa stock chassis wiring na nagmamark lang sa junction. Ang mga fusible link ay isang redundant na system para sa pag-protect ng mga circuit. Maliban din sa ibinibigay sa starter motor, lahat ng iba pang kuryente ay dumadaan muna sa mga fusible link at after nun ay sa mga iwalay na circuit fuse. Maaaring matunaw din ang isang fusible link nang hindi pumuputok ang fuse. Ang mga fusible link ay inilalagay malapit sa battery para direct na maprotektahan ang mga wiring at circuit. For the next is mega fuses. Many newer vehicles are equipped with mega fuses instead of fusible links to protect high amperage circuits. Circuits often controlled by mega fuses includes the charging circuit, HID headlights, and heated front or rear glass. The mega fuses are high current protection devices that are used to protect critical electrical components like batteries, alternators, and heavy gauge wiring. They are best for high electrical demand vehicles like cars, trucks, SUV, off-road vehicles, buses, and watercraft. Ang mega fuses ay ito yung mga protection na fuse na ginagamit para maprotektahan ang mga critical na part ng electrical system like yung mga battery, alternator, at mga mabibigat na copper. Karaniwan itong ginagamit sa mga sasakyan o sa kagamitan na may mataas na pangangailangan sa kuryente tulad ng mga kotse, truck, SUV, off-road na mga sasakyan, bus, and others. And ang mega fuses din ay tumutulong para ma-prevent yung damage sa mga electrical na part kung sakaling magkaroon ng labis na kuryente dumaan sa system. Yung nasa image naman, ito yung 125 ampere rated fuse na ginagamit para makontrol ang current mula sa alternator. May tech tip din dito para mahanap yung pinaka-root ng cause. Dapat bago palitan ang isang nasirang mega fuse o fusible link, mahalagang malaman muna yung pinaka-cause ng problem. Maaaring masira ang isang mega fuse dahil sa vibration or may physical damage dahil naman sa aksidente o kalawang. Kung maluwag ang fuse, dapat ding palitan. Pero kung ang pagkasira ay cause ng excessive current, dapat na magsagawa ng investigasyon para sa mga aksidente o iba pang dahilan na nagdudulot ng labis na pagdaloy ng kuryente. Kasama din sa investigasyon ang lahat ng mga electrical na part na tumatanggap ng kuryente mula sa fusible link. After matukoy at maitama ang cause, maaari nang palitan ang fusible link o mega fuse. Next is checking fusible links and mega fuses. These are usually located near where electrical power is sent to their fuses or circuits such as starter solenoid battery terminals, second, power distribution centers, third, output terminals of alternators, and lastly, positive terminals of the battery. Ang mga fusible link ay pwede ring matunaw pero hindi makikita sa external evidence na damage. Para ma-check, dapat na maingat na hilahin ang bawat dulo. Kung ang insulation ay humihigpit, ibig sabihin nun ay yung nasa loob na kawad ay natunaw na at kailangan ng palitan ang fusible link. May alternative din, maaari din gamitin ang test light o voltmeter upang i-check ang voltage sa parehong dulo. Kung ang voltage ay nasa isang dulo lang, ang link nun ay electrically open at kailangan ding palitan. These are the steps for replacing a fusible link. For step 1, safety first. Before starting, disconnect the negative terminal of your vehicle's battery to prevent any electrical hazards. For step 2, locate the fusible link. Fusible links are typically found near the battery, fuse box, or along the wiring harness. They are usually shorter sections of wire with a different insulation color. Refer to your vehicle's service manual for the exact location. For step 3, identify the damaged fusible link. Once you located, determine which fusible link is damaged. It's often difficult to visually inspect fusible links, so if you experience electrical issues, it's prudent to check them. For step 4, remove the damaged fusible link. Using wire cutters, carefully cut the fusible link out of the circuit, ensuring you leave enough wire on both sides for splicing. And note the wire gauges and colors on both sides of the fusible link to ensure proper replacement. For step 5, prepare the replacement fusible link. Obtain a fusible link of the same gauge and amperage rating as the original, and fusible links are designed to protect specific wire gauges and circuits. And if you can't find an exact replacement, you can create a fusible link by using a piece of wire 2 gauges smaller than the existing wire and wrapping it with fire resistance insulation. For step 6, install the new fusible link. Strip about ½ inch of insulation from both ends of the existing wires where the fusible link was removed, and connect to the new fusible link to this wire using appropriate connectors or by soldering, or ensure the connections are secure and insulated to prevent short circuits. For step 7, re-insulate and secure. Use electrical tape to cover any exposed connections. If the fusible link was originally covered with a protective hood or sheet, replace it to safeguard against moisture and abrasion. And step 8, reconnect the battery. Once the new fusible link is securely installed and insulated, reconnect the negative terminal of the battery. And last step, step 9, test the electrical system. Turn on your vehicle and check the circuits protected by the fusible link to ensure they are functioning correctly. And lagi din nating tatandaan na palaging gumamit ng fusible link na may same amperage rating o mas mababa kaysa sa original para ma-sure natin yung tamang protection. And iwasan din yung pagpapalit ng fusible link gamit yung karaniwang copper dahil maaari itong mag-cause ng mga sunog sa kuryente dahil sa shortage na protection. Kung hindi ka komportable sa paggawa ng pagpapalit, dapat kang humingi ng help sa mga professional na mekaniko o electrician. Next is electrical terminals and connectors. A terminal is a metal fastener that is joined to the end of a wire, and it is what creates the electrical connection. The word connector typically denotes the plastic component that snaps or mates together, thus creating the mechanical connection. Wire terminal ends typically snap into and are retained by a connector. Male and female connectors may then be snapped together, thus forming an electrical connection. Environmentally exposed connectors also have a weather-tight seal, and terminals are retained in connectors by the use of lock tang. Removing a terminal from a connector includes the steps. The step 1 is release the connector position assurance or CPA if equipped, that keeps the latch of the connector from releasing accidentally. For step 2, separate the female and male connector by opening the lock. For step 3, release the secondary lock if equipped. And for step 4, using a pick, look for the slot in the plastic connector where the lock tang is located. Depress the lock tang and gently remove the terminal from the connector. What is wire repair? Ang wire repair, ito naman yung processing o pag-aayos ng mga nasira o may defective na copper sa isang sasakyan. Ito ay isang mahalagang process para mapanatili ang integridad ng system ng kuryente ng sasakyan. Para magpatuloy yung maayos na operasyon ng mga part nito tulad ng mga ilaw, sensor at iba pang gamit para sa electronic. There are a method of wire repair. The first method of wire repair is crimp and seal connectors. For the process, these connectors combine a metal crimp sleeve with an adhesive line heat shrink tubing. When heated, the adhesive seals the connection, providing both mechanical strength and moisture resistance. The advantage of this is quick and straightforward installations and maintain the wire's flexibility, which is beneficial in applications subject to movement or vibration. And the adhesive creates a waterproof seal, protecting the connection from corrosion. For the second method of wire repair is solder and adhesive line heat shrink tubing. The process of this method involves soldering the wire ends together to establish an electrical connection. Then, covering the joint with heat shrink tubing that contains an adhesive. Heating the tubing causes it to shrink and the adhesive to flow, encapsulating the connection. The advantages of this method is soldering can provide a low resistance electrical connection. Second, the adhesive line heat shrink offers a waterproof seal, protecting against moisture and corrosion. For the third method of wire repair is solder and electrical tape. The process of this method is after soldering the wire ends together, the joint is wrapped with electrical tape to provide insulation and mechanical protection. The advantages of this method is soldering ensures a strong electrical bond, and electrical tape is easily applied and readily available. For additional insights, crimping versus soldering, crimp connections are generally preferred in automotive applications due to their resistance to vibration and movement. Soldered connections, while providing a strong electrical bond, can become brittle and prone to failure under mechanical stress. And corrosion resistance, both crimp and solder methods can achieve corrosion resistance when combined with appropriate sealing techniques such as adhesive line heat shrink tubing. For the best practices for optimal results, it's recommended to use high quality connectors and materials. Ensure proper installation techniques and consider the specific applications requirements such as exposure to movement, moisture, and temperature variations.
Hi guys, I'm Tim, and whether you're an aspiring automotive technician or a seasoned pro, you'll know there is one thing that everyone recommends to do when attempting to diagnose the cause of an electrical fault on a vehicle. Check your wiring. Well, that's all well and good, but it doesn't mean you should just give it a once-over and a few taps. It also involves checking the electrical integrity of the wire and quality of its connectors and terminals. While these might seem simple enough, doing them incorrectly can mean potentially damaging the sensitive electrical systems that keep modern cars running. But before we jump right into the do's and don'ts of diagnosis, let's quickly have a closer look at the anatomy of wiring and connectors in an automotive electrical system. All the wiring in a vehicle will be made up of multiple tiny copper strands surrounded by an insulating thermoplastic outer layer. The copper acts as the conductor for the electrical current travelling from the battery, and the outer layer protects these strands from heat, moisture, and from shorting to any other conductive material. Multiple wires are usually needed for various components within a vehicle, so for organisation, they are grouped together in looms. And at the end of these looms are connectors which join sections of wire together. Inside these connectors, individual wires are attached to terminals which act as the endpoints of the wires and connect to corresponding pins on a plug, providing a secure connection. Now, the major thing that can go wrong with wiring is damage to the insulating protective layer surrounding the copper strands. In an automotive system, heat and vibration can wear this protective layer down and cause moisture to get into the copper strands, causing a high resistance for the electrical current going through the wire. This causes all sorts of problems with the electrical components on a vehicle and can sometimes be very difficult to see with the naked eye, especially when looking at thick wiring looms that snake here, there, and everywhere. This is why it is important to know how to properly test the electrical integrity of each wire in a safe and accurate way, and the best practice for this is back probing. Back probing involves using a multimeter equipped with a pin or backpin probe and inserting it next to a wire on the rear of a connector in order to investigate the wire's integrity. This testing method is king in the automotive diagnostic world as it doesn't risk any damage to the wire's insulating layer or terminal, and you don't have to remove any connectors to carry it out. This is especially beneficial now that modern vehicles use larger connectors with more terminals, which can be from multiple different systems within the vehicle. So live testing with everything powered up and connected is a lot easier. To carry out an effective back probe test, you will first need to remove the back cover from the connector to expose the rear of the affected wire's terminal. Then, with your pin probe attached to your multimeter, carefully slide the probe down the side of the wire, ensuring it doesn't damage the wire insulation or any weatherproof seal. The pin will usually be able to be inserted further at a certain point due to the orientation of the terminal within the connector. So it is worth trying to insert the probe at least 2 points on the side of the wire to determine where the terminal is. You may want to carry out a back probe test on a known working wire first in order to properly determine the orientation of the terminals on the connector, so you can confirm you are getting an accurate reading when testing the suspect wire. So now you know how to back probe. Let's look at how you can use this technique to identify what kind of fault is affecting a suspect wire. These can usually be categorized into three main circuit failures: a short, an open, or high resistance. High resistance is usually caused by corrosion of the internal copper strands, poor terminal contact, or overheating damage to the wire caused by high current draw. To test for this, turn your multimeter to ohms and check the continuity of the suspected wire. For a standard 12-gauge automotive wire, the resistance should be less than 1, based on the assumption that it should have a resistance of less than 0.026 ohms per meter of wire. Another way of diagnosing high resistance in a wire is to conduct a voltage drop test. This is especially beneficial when diagnosing damage to a wire caused by high current draw. And it is a better way to test for resistance because you are testing with everything powered up and functioning. To do this, ensure the vehicle is running and you have put the battery under load by turning accessories on such as the aircon and radio. Turn your multimeter to volts DC and back probe either end of the wire at each connector. You shouldn't see more than 0.2 volts on most Automotive 12-gauge wires, but it is worth consulting your manufacturer's specifications before condemning the loom. An open circuit can be diagnosed again by checking continuity of the wiring, but instead of getting a high resistance reading, you will see OL or open circuit on the multimeter. These faults are caused by a complete break in the wiring caused by severe corrosion, damage from an external overload, or from general wear and tear over time. The other causes of an open circuit could be due to poor terminal tension. A short circuit occurs when the copper wire strands of two or more different circuits touch each other directly, causing the electrical current to flow through a different path than intended and resulting in a surge of electrical current. They can occur either when a damaged live or current-carrying wire makes contact with a damaged ground or low reference wire, which is called a short to ground, or when one current-carrying wire makes contact with another out of the intended circuit path, which is called a short to voltage. To test for a short in an automotive circuit, you should set your multimeter to volts DC and back probe the affected wire and test it against either a known good ground or a supply voltage, depending on the wire in question. If you get a reading outside of the desired range, then isolate the suspect wire from the rest of the circuit and retest. In this example, set your multimeter to ohms and perform a continuity test between the negative side of the battery and the affected wire. As this wire has been removed from the terminal, there should be no continuity between it and the battery ground. So if there is any resistance displayed, then you can assume the wire is shorted. Now you know how to back probe and find a fault in your wiring, but how do you fix it? Well, here you have a few options. You can either completely remove and replace a damaged wire if access is easy enough, or cut out the damaged section of wiring. Bear in mind that every time you cut and rejoin a wire, you're creating a potential point of weakness for ingress to enter. So ensuring you are properly repairing any damage is pivotal. There are a few methods of rejoining a wire, but start by cutting each side of the damaged wire using precision side cutters to get a clean cut, and then strip each end of the wire using appropriate sized wire strippers. Now this is where the methods of repair differ, and these can be affected by the amount of slack you have with a wire or the space you are working with. A crimp sleeve is the easier method of repair as they are straightforward to use and provide more slack to a wire. The two important things to remember when using these are: 1. Use a good crimping tool such as a ratchet crimper to ensure the connection is solid and even, and 2. Always use a heat shrink cover as a crimp sleeve isn't weatherproof. The other method to repair a broken wire, which we would recommend, is to solder it back together. The important thing here is to make sure you are twisting the wires together tightly to create a strong joint. Then apply the soldering iron to the joint, followed by the solder, and allow it to flow all over the connection. This will create a joint which has a solid and reliable electrical connection, and it is the best practice when repairing wires. Always remember to apply a heat shrink sleeve to keep the repair safe from the elements. Now, damaged wiring is only one half of what can be faulty within a wire. The second thing to check for is terminal tension and connector corrosion. The corrosion is fairly simple to spot. Just remove the connector and visually inspect both ends for any crusty buildup or discoloration. Terminal tension tests involve a little more know-how and the correct tools. So before you start, you will need the correct size terminal drag tool for the connector you are working on. Kits usually come with tools of various different sizes, so make sure you are using the correct one to get a reliable reading. Insert the drag tool into the affected terminal and slowly pull it out. There should be a noticeable resistance or drag as you remove it if the terminal tension is good. If the tool is removed easily or it has a noticeable amount of wiggle room, then you will need to replace or retension the terminal. To do this, you will firstly need to remove the terminal from the connector. This can be a slightly different process depending on the connector, but the main steps are the same. So start by removing the connector from the corresponding plug. If you haven't done so already, remove the back cover of the connector to expose the back of the wires. This may require removing the locking mechanism, especially on larger connectors. Then remove any secondary lock or terminal position assurance device from the front side of the connector to expose and free up the terminals. Different connectors have different sized terminals with different locking mechanisms, so you will need to make sure you have the correct terminal removal tool for the job and know which side to approach the terminal's locking latch from. Press the release tool into the terminal's locking latch and wriggle the wire free out of the back of the connector. At this point, you can either remove and replace the terminal with a new one or attempt to retension the faulty terminal. Again, this process may differ depending on the design, but having the correct tools is key. And there we have it. We hope you enjoyed our crash course on automotive electrical wiring, diagnosis and repair. Let us know if you would like to see more videos like this in the comments, and don't forget to like and subscribe to help out the channel. Thanks for watching, and I'll catch you next time.
For additional tips, wire matching: always use wires of the same gauge and insulation type as the original to maintain electrical integrity. When soldering, apply heat only until the solder melts to prevent damage to the wire insulation. And if uncertain about the repair process or dealing with complex wiring issues, seek help from a qualified technician to ensure safety and compliance with electrical standards. For my conclusion, to conclude, automotive wiring is essential to provide proper vehicle electrical system functioning by facilitating power and signal transmission. Copper wires with connectors, terminals, and protective devices such as fusible links and mega fuses ensure effective and safe operation. The high conductivity and flexibility of copper with protective elements avoid possible electrical risk, including fires. Regular inspection and maintenance of these parts are necessary to provide a vehicle's electrical system with longevity and safety so that it can function effectively and securely. And these are my references. And that would be all for my topic today. Thank you for your attention. And for my quiz, I will send through the chat box of our MS Teams, and you can start to take the quiz. Thank you.